In question one, there was actually a mistake because some of the answer choices were supposed to have parallel lines instead of congruent lines. So answer choices 2 through 4 are actually exactly the same answer choice. And the only one that's different is answer choice number one. Answer choice number one has AB congruent to CD and AB, the same segment, congruent to DC, the same segment. So with that information, there's only one pair of congruent sides. The other three answer choices have both pairs of congruent sides, making it a parallelogram. So due to the error in the answer choices, the only answer choice that could be it was answer choice number one. Okay. Number two, if we're showing that we don't have a square, then it needs to not be a rhombus and a rectangle at the same time. So we're looking for the answer choice that does not have both a rhombus and a rectangle property. So the diagonals are both congruent. Congruent diagonals is a rectangle property. And perpendicular, that's a rhombus property. So this choice is a square because it does have a rectangle and a rhombus property. For the next answer choice, the diagonals are congruent. Once again, that's a rectangle property. And one pair of adjacent sides are congruent. That is a rhombus property. That's the same thing as saying consecutive sides are congruent, which, as we know, implies that all of the sides are congruent to each other. So that is both a rectangle and a rhombus. That one is a square, not the answer choice that we're looking for. Answer choice 3. The diagonals are perpendicular. That is a rhombus property. And one pair of adjacent sides are congruent. Once again, that is a rhombus property. So this is the answer choice we're looking for. It does not have both a rhombus and a rectangle property. It only has a rhombus property. So it would not be enough to prove that we have a square, because in order to be a square, it has to be both a rhombus and a rectangle. For answer choice 4, it does have a rhombus property, diagonals are perpendicular, and a rectangle property. One pair of adjacent sides being perpendicular means that two sides next to each other form a right angle. Perpendicular lines form right angles. And we know that if our parallelogram has one right angle, all of the angles are right angles, and that makes it a rectangle. So the answer choice here that would not show a square is answer choice 3 because it does not have both a rhombus and a rectangle property. It only has two rhombus properties. For number 3, asking which answer choice must be true about parallelogram ABCD. So the first answer choice says that BE is congruent to CE. Now that is actually not true because in a parallelogram, diagonals bisect each other, but the diagonals don't necessarily have to be equal to each other. So this diagonal is being split in half, and this diagonal is also being split in half, but these diagonals can definitely be different. If this diagonal is 8, this is 4 and 4. If this diagonal is 10, this is 5 and 5. It does not need to be the same. BE would be congruent to CE if this was a rectangle, because a rectangle does have congruent diagonals that also bisect each other. So this one would be true if we had a rectangle, not with a regular parallelogram. Answer choice 2. Angle BAE is congruent to angle DCE. This is true because parallelograms have parallel opposite sides, and we know that when parallel lines are cut by a transversal, we do have congruent alternate interior angles. And angle BAE and angle DCE are alternate interior angles. They are in the corners of the letter Z that you can see here. So that is the true statement. That is the answer choice that we are looking for. We can go through the other answer choices to see why they are not true. AB would only be congruent to BC if this was a rhombus, because rhombuses have 4 equal sides. They have congruent consecutive sides. Regular parallelograms don't have that. They only have opposite sides that are congruent to each other. And finally, answer choice 4, angle DAE, that's this angle over here, is congruent to angle CBE. That's this angle over here. That would not necessarily be true because angle A, the whole angle, and the whole angle B here are supplementary to each other. And we don't know how each angle is being split in half. Not only do we not know the total angle measurement, but we don't know how each is being split because this is not a rhombus, so we don't know that the diagonal is bisecting the angle. So these could actually have any measurement. We really don't know the relationship between them here. So answer 2 is the only statement that absolutely has to be true because they are alternate interior angles when we have parallel lines cut by a transversal. Number 4, we do have a rectangle, and rectangles have congruent diagonals, and that's a property we're going to need here because they do tell us the length of diagonal RT, and they do also tell us a piece of diagonal US. They tell us that this is 7x minus 6. So I know that the other piece is also 7x minus 6 because rectangles are parallelograms, so the diagonals do bisect each other. That means each diagonal is being equally split in half into two congruent parts. So if this half is 7x minus 6, this half also has to be 7x minus 6. And I do know that the diagonals are congruent to each other in a rectangle. So I can make an equation that says the whole diagonal US, so double the 7x minus 6 because it's happening 2 times to make the whole diagonal, is equal to the other whole diagonal, which is 6x plus 4. We can really quickly solve this equation. We have 14x minus 12 is equal to 6x plus 4. Subtract 6. That is 8x. Add 12. That is 16. And it is asking for US, not the X value. The X value is always there to trick you. So we need to plug in to find the length of the entire diagonal US. It doesn't matter where you plug into because both diagonals are congruent. So I'm going to plug into 6x plus 4. 6 times 2 is 12, plus 4 is 16. So the correct answer is answer choice 3, 16. Okay, here we have a trapezoid with parallel bases. And we do know that this angle is 4x plus 20 and this angle is 3x minus 15. And they do also tell us, key piece of information is that the legs are congruent. So we do know that this is an isosceles trapezoid. And since it is an isosceles trapezoid, the base angles are congruent to each other. And we know that any upper base angle and the lower base angle directly below it are supplementary because they are same side interior angles formed when parallel lines are cut by a transversal. And we know same side interior angles are supplementary when we have parallel lines cut by a transversal. So when we add them together, they should add up to 180 degrees. So that is 7x plus 5 is equal to 180. That is 7x equals to 175. And that gives me an x value of 25 if you divide both sides by 7. Once again, the x value is always an answer choice, but they're not asking for the x value. They're asking you to plug in for the measurement of angle D. So that would be 3 times 25, which is 75, minus 15, which is 60. So 60 is the measurement of angle D. Okay, the next question over here, we have a rhombus, and we're given information about the diagonals of the rhombus. We're also going to keep in mind that the diagonals of a rhombus bisect each other because that is a property of parallelograms that also applies to rhombuses. And we're also going to keep in mind that diagonals of a rhombus are perpendicular, meaning that they form 90-degree angles where they intersect. What we have here are 4 right triangles. We know that this whole diagonal over here is 16. So that means that each half would be 8. And we know that this diagonal over here is 30. So that means each half would be 15. We're looking for the perimeter. So in order to find the perimeter, we need a side length. And then once we have a side length, we know all side lengths because rhombuses have 4 equal sides. So what we have here are 2 legs of our right triangle, and we need to find the hypotenuse. And that's going to be Pythagorean theorem when we have 2 sides of a right triangle and we need to find the missing side. Let's plug in 8 and 15, and we are solving for the hypotenuse, so we are solving for C. That's 64 plus 225 is equal to C squared. So that is 289 is equal to C squared. And then if you square root both sides, this works out very nicely to a nice number of 17. So since this is a rhombus, that means all the side lengths are 17. 17 times 4 is 68. And that one is all done. Moving on to the next one. I'm just going to take a minute and grab it, even though the use of the grid is optional. Let me pause the video. So here I have my quadrilateral ABCD graph, and the question's asking for three things. First, it's asking us to show that it's a parallelogram, and then to show it's not a rhombus and not a rectangle. So first things first, we have to start off by showing it's a parallelogram. That's what comes first before we can even think about it being a rhombus or a rectangle. So one is going to be to prove that we have a parallelogram. So I'm going to do that with slope formula because looking at your test, that's what a lot of you guys did as well. So I'm going to find the slope of AB. I'm going to find the slope of DC. And once again, this is not the only way to do it using slope formula. I'm just choosing to use slope formula. I'm going to find the slope of AD, and I'm going to find the slope of BC. Yes, you need to find the slope of all four sides to prove that you have a parallelogram, because it's not just one pair of opposite sides parallel. It's both pairs of opposite sides parallel to prove that you have a parallelogram. I'm going to use rise over run like a lot of you guys did. You can use slope formula as well, but rise over run is just going to be a little bit easier. So I'm just going to count the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that was, I think I messed that up. No, 1 over, and 1, 2, 3, 4, 5, 6, 7, 8, and 9 up. It's a decreasing line, so that's going to be a negative slope. So that is a negative 9 over 2. And I should expect this to have the same slope, but let me just count just to be sure. And I have to show that I'm counting, so I know that the numbers, didn't get made up from somewhere. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there we go. Same slope, that worked out. Okay, now I'm going to find the slope of the other two opposite sides. And these are straight horizontal lines, so they're going to have a 0 slope, but we can count anyway. So there is no rise, so that's 0. And then our run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that is a 0 slope. And this opposite side also has the same 0 slope. You count the boxes. You can also use slope formula if that is not very easy for you to see. I'll write this as just 0. So 0 is a slope. All horizontal lines do have 0 slopes. So I'm going to just explain what I found in words as my concluding statement. Since both pairs of opposite sides are parallel, ABCD is a parallelogram. Now, since I already have the work for it, I'm going to explain why it's not a rectangle. Because using slope formulas, I showed that there's no opposite reciprocal slopes. Two sides next to each other don't have opposite reciprocal slopes. We have negative 9 over 2 and 0. Those are not opposite reciprocals of each other. So there's no perpendicular lines, meaning that there's no right angles here. And if there's no right angles, it can't be a rectangle. Since there are no opposite reciprocal slopes, there are no right angles. So ABCD is not a rectangle. And now the last thing to do is show that it's not a rhombus. I don't have enough work for that. There are two ways that I can show that it's not a rhombus. Either I can find the slopes of the diagonals and show that they're not perpendicular to each other, or I can find the length of two sides next to each other and show that they're not the same. I'm just going to find the length of two sides next to each other. So I'm going to find the length of AD, and length is distance formula. So let me plug in really quickly. 6 minus negative 5 squared Oh, I'm using the wrong coordinates. I was using AB. Okay, let me use AD this time. -3 minus -5 squared. -3 minus 6 squared. And I got radical 85. And then I'm going to find the slope of one of the sides next to it. So I'm going to just find the slope of DC. Sorry, not the slope, the length of DC. Using the distance formula once again. Okay, and I got 11. That one. So let me put my concluding statement here. Since consecutive sides are not congruent, ABCD is not a rhombus. There we go. Okay, moving on to the next question. So before we write the proof, I'm going to go through the plan. There are multiple ways to do this proof. There is one with proving two triangles congruent and then using the addition postulate in order to get FA and GS, but I'm going to do it the easier way. I'm going to do it by proving these two triangles congruent and then just CP-CTCing the two sides that we need. And the two sides that we're trying to prove congruent are FA and SG. So I do want to focus on, just to avoid as much work as possible, I do want to focus on this triangle and this triangle because they already have FA and SG as sides. So if I can prove these two triangles congruent, I can just CP-CTC FA and SG, and that cuts down on work. Also, only FS is a diagonal. LH, that's not even a segment, but LH would be a diagonal, but we don't have that. We have LG and AH. So the only diagonal here is FS. So it's not going to be possible to use any diagonal properties because the only diagonal property of a parallelogram is that diagonals bisect each other, and that requires two of them if they're bisecting each other. Since we have a parallelogram, the opposite sides are parallel, and they're also congruent to each other. And we know when we have parallel lines cut by a transversal and we have the letter Z, we have congruent alternate interior angles. So now I have my two triangles congruent by angle, angle, side because I have the right angles from the perpendicular lines in the givens. And then I can just CP-CTC, FA, and SG. I'm going to write up the proof. I'm going to pause the video and then I will display it. And here's the proof. Feel free to pause the video so that you can take a look at it. Okay, over here, we are proving that we have a rhombus. What we know is that we already have a parallelogram. We also have information about perpendicular lines. BE is perpendicular to CED. So I know that they're going to form right angles where they intersect. So here's BE and here's CED. So where they intersect, they're going to form two right angles. And I also know that DF and BC are perpendicular. So where they intersect, they're going to form two right angles as well. Now, the reason that I only put in this right angle and this right angle instead of both of these, because these are right angles as well, is because I put a hint here, look out for overlapping triangles. So one overlapping triangle is this one, and the other overlapping triangle is this one. So if you draw them separately on your paper, which is one of our strategies for working with overlapping triangles, that and color coding, which are both good to do, you will see that this right angle is actually an angle in the blue triangle, and this right angle is actually an angle in the yellow triangle. So already we have a pair of congruent angles that we can work with in order to prove the triangle's congruent. Now, we know that we want to prove the triangle's congruent because our end goal is to prove that we have a rhombus. And there's only three properties of a rhombus that will make it a rhombus. And two of them have to do with diagonals, diagonals bisecting the angles or diagonals being perpendicular. And neither of those are going to apply here because we don't even have diagonals. Diagonals go from corner to opposite corner. We don't have BD. We don't have AC. We don't have any segments that are diagonals here. So it's going to come down to the only property that is not related to diagonals, that sides are congruent. So as long as we can show that two sides next to each other are congruent, so here BC and CD would be our best options because BC and CD are sides of the triangles that are overlapping. So if we can prove the yellow and the blue triangle is congruent, then we can just CPCTC, BC, and CD, and then we'll have that it's a rhombus because consecutive sides will be congruent. So whenever we have overlapping triangles, there's always going to be something shared. It's either going to be a side or an angle. So if you can't see it from the original diagram, look at the separated triangles and see what letters are the same. And there's only one letter that's the same, C and C. And that tells us that angle C is shared between the two triangles. So we can say it's congruent to itself by reflexive property. If there were two letters that were the same, that would mean a side was shared. But since there's only one letter that's the same, there is a shared angle. Angle C is the same angle in both of the triangles. And in the givens, they also give us one more piece of information that I am forgetting to put in. They do also tell us that CE is congruent to CF. So here's CE and here's CF. And that's all we need for ASA. Once we have ASA, we can CPCTC, BC, and CD. And then we can say that ABCD is a rhombus because consecutive sides are congruent. I'm going to pause the video and I'm going to write this up. Here is the proof. Feel free to pause the video and take a look. Okay, and the last question was the extra credit, and I am going to go over the most direct way to do it. You can do it a bunch of ways, including proving a lot of different triangles congruent and CPCTCing a lot of stuff, but we're not going to do it that way. We do have diagonals here, because we do know that FJHG, the outer quadrilateral, is a parallelogram. So we do have its diagonals FH and JG, corner to corner, corner to corner. And we do know that diagonals of a parallelogram bisect each other. So FO is congruent to OH and JO is congruent to OG because diagonals of a parallelogram bisect each other. From the givens, they also tell us that FK is congruent to HL. If you take FO minus FK, you'll be left over with KO. And if you take HO minus HL, you'll be left over with OL. And now we know the inner quadrilateral is a parallelogram because its diagonals bisect each other. If diagonals bisect each other, that means that it is a parallelogram. So that would only be a couple of steps. That would be one step saying FO and HO are congruent, and JO and GO are congruent. And that's because diagonals of a parallelogram bisect each other. So that's up to step 2 after the givens. We would need the subtraction FO minus FK is congruent to HO minus HL. So that would be step 3. And then we would have step 4, KO is congruent to OL. That would be by substitution. And then step 5, KGLJ is a parallelogram. If diagonals bisect each other, the quadrilateral is a parallelogram.